So we're going to find our instantaneous rate of change of our function g of x, which is describing the function 1 over 3x cubed minus 2x plus 2. And we're going to be finding this when x is equal to 2. G of x is in a polynomial form, so we can use it as equal to kx to the n, and g prime of x is equal to kn x to the n minus 1. Now to find the derivative of g of x, so our g prime of x is going to be equal to the derivative of this part here. So we've got a 3, that'll come down the front, and we'll have 1/3 times 3, which is going to be equal to 1. So we're just left with a 1, which is still there, but we don't write it. Our 3 becomes our 3 minus 1 is equal to 2. Our next step is our minus 2x. Well, the 1 from the x comes down to the front and gives us 2 times 1, which is going to give us minus 2. Our x to the 1 minus 1 is equal to 0, so that's x to the 0 is equal to 1, which we just leave it as 1 and we just don't write it. And finally, our plus 2 doesn't depend on x, so we don't even bother writing that. Now we just put in our value of 2, so our g prime of 2 is going to equal to 2 squared minus 2. 2 squared is 4, 4 minus 2 is 2, so our derivative at x equals 2 is also equal to 2. This looks like on the graph, where our function is given at the top here of g of x is equal to 1/3 x cubed minus 2x plus 2 is this function below. And we looked at the point when our x is equal to 2, so that's at this point here. So if you remember our derivative, so g prime of x is equal to x squared minus 2. And we saw that our g prime of 2 is also equal to 2. That gives us our slope here is heading positive at a gradient of 2.